Hi, so you can see here that right now we're playing Good Time by Carly Rae Jepsen, which is one of my favorite songs. This headphone set is actually connected to a BeagleBoard XM by ARM, which is basically like a mini portable computer. Portable because it can be wireless if you use a battery pack. Right now, this BeagleBoard is running Ubuntu Linux, and it has OpenCV installed on it, as well as a GUI desktop and an MP3 player and video camera drivers. So what have we accomplished so far with this system? Well, this system is a great step to our final project in terms of what we want to do with a mobile device and OpenCV. Currently on this device, we are able to output sound, as you can see, from a 3.5mm sound audio jack output, which is what this speaker is connected to. And we are powering it with a 5-volt, 3-amp power source, which is plugged into a wall, but eventually that will be replaced with a battery pack, and they are freely available on the market, and we have verified from several sources online that this is possible. And in terms of what our system can do right now, currently we are able to, let's see here, we can use OpenCV to do template matching. So let me just demonstrate that right here. So right now we have OpenCV installed with Python bindings, and I'm going to show you a demonstration of template matching with OpenCV. So here you can see the result of the template matching. We have a box on top of the stop sign. This is the result of our template match algorithm. Basically what we did was we inputted a small template image. Let me see if I can show it to you guys on here. Let's see here. So basically we inputted a small template image like this. It's just a stop sign, and we put it into our database, and it matches it with any input image that we have. So the input image is this one, a sky with a stop sign in it, and basically it overlays these two images, and you can see the high correlation, and it is matched by a box. So this is the place with the highest correlation coefficient between the two images, and it has matched a stop sign. So that is what we were able to do with template matching and OpenCV, and this is all completely done on the BeagleBoard XM. In fact, this whole entire desktop GUI is linked to the BeagleBoard XM via an HDMI cable, as you can see here. It is linked directly to the screen. We are not using a desktop whatsoever. This is completely all on the board. Another thing that we're able to do on this system is, let's see here if I can demonstrate this, video output. We have a Logitech 9000 video camera that takes in images live and outputs them. So we're going to do this on OpenCV and see if OpenCV can open the video cam and capture images. So we're going to do that right now. Video PY. So here is the output from the video camera. As you can see, it is taking a video capture of Deakin Lab right now and everybody that's working in it. In fact, here I am right now. And basically this is great. This has confirmed that yes, indeed, we can run video outputs on OpenCV inside a BeagleBoard, and is able to take in all these inputs, and it works. So what does this mean? So far we have an infrastructure ready. We have video camera input and output through OpenCV working. We have template matching working with Python bindings in OpenCV running as well. We have Ethernet ports where we can download our software and import all our code. Currently, the majority of our code is in C++. However, we are gradually replacing the C++ code with Python. In fact, the two codes that you see here right now were all built in Python, and they were translated from C++ code that we had previously. So it's very doable. And we also have, right now our system seems really wired because it's like keyboard, mouse, we're trying to like configure everything, but once this is all configured, what is going to happen, we think hopefully in the future, is that we're going to be running OpenCV continuously on this BeagleBoard. We're going to detach everything like the Ethernet, the USB cable for the keyboard and the mouse, and the HDMI cable. However, we will be leaving the speakers, which were shown in the beginning. We don't know if we're going to be using headphones or loudspeakers. That's something we're going to leave to do for a survey with visually impaired individuals to see which one they prefer most. And we are going to replace the current power source, which is a 5-volt, 4-amp power source that's connected to the wall, with a battery pack, which can supply the same amount of power. And we have verified that this can be done online. And in terms of constraints, so constraints are that from researching what other people have done, it seems that we definitely need to get a larger micro SD card. Currently we're running on 4 gigabytes, and half of that memory has already been taken by installing all the Ubuntu systems, the OpenCV, the images. Everything we have so far has taken even more than half, and it's, it's running, like the OpenCV part's running pretty quickly, but everything else, like the speed of the internet, the speed of just how things are moving around on the screen, just seems a little bit slow, a little bit like frozen a bit. So we definitely know if we can upgrade our micro SD, things will go a lot faster, and this is great for performance levels. But this is currently a diagnostic, and it's a great start to verifying that our system indeed can work on this embedded system. And another constraint that we know of is that the video cam can't process more than several hundred frames per second. So we're going to lower those frames per second to a target goal of 20 frames per second. To the human eye, this actually isn't too bad because we need to identify signs, right? And if we can identify, if we can get 20 verifications even in 1 second, that's already going a great long way in terms of measuring our accuracy. So another thing is, so once we decrease the frame rates, we also have to deal with resolution, so we may have to go to a lower resolution, so that's another constraint as well. And yeah, so that's pretty much it. Those are like the constraints of what we need to do. And so, yeah, this is a great start to our project, and hopefully we will see more coming out of it. So all we have to do is port the code from our current Linux-based desktop system to our BeagleBoard system and see how it works all together. So that's going to be a big challenge in the next month or two, and I look forward to working on it. And if you have any questions, please feel free to ask us. Thank you.